In question 4, we have a projectile fired up a hill with speed 10 meters per second, and it's angled 75 degrees to the horizontal. So here's my U of 10 meters per second, and we have two angles. We have 75 degrees for the total angle, and the hill is inclined at an angle 45 degrees to the horizontal. So I've got a 45 in here and a 30 in here to give me my 75 degrees. So setting up my initial, my U1 is going to be U cos 30 in the I direction plus U sine 30 in the J direction. Cos of 30 is root 3 over 2, so we're going to have root 3 U over 2 in the I direction, and the sine of 30 is a half, so U over 2 in the J direction for my initial vector. So giving the 10 for U, we're going to get 10 root 3 over 2, so it's going to become 5 root 3 plus just 10 over 2, 5 in the J. So my velocity vectors, v of x or v of I, U plus AT, the U being the 5 root 3. So you can see we need A. So A in the x direction and A in the y direction. They're both negative here, so minus G by the sine of 45 for x, and minus G by the cos of 45 for J. So minus G over root 2 for both. So here we have minus G over root 2 times T. Then the velocity in the y direction is going to be the 5. And we're going to have minus G over root 2 times T. Then looking at displacements, S of x is equal to ut plus a half at squared. So we're going to get u, which is 5 root 3 times t. And then we're going to have plus a half times the minus g over root 2. So we're going to have minus g over 2 root 2, the half being the 2 part, and then the root 2 to g over root 2. And then that's times t squared. And then for y, displacement in y is going to be du, which is 5, so 5t, and the accelerations are the same here, so they'll work out the same, gt squared over 2 root 2.